Thank you very much for inviting me to speak today. As you said, I'm the team manager of our sustainability team within the buildings division here in Sweco in Denmark. And just briefly about me, I initially started as a structural engineer when I graduated 5 years ago, but I specialized during my studies in life cycle assessments and was really keen to pursue a career within sustainability and calculating the CO2 emissions from our materials and our buildings. So that's what I pursued then. And now I'm in Sweco here in Denmark. I'd like to start out with talking a bit about life cycle assessments and really just setting the scene. I'm sure many of you know, but when we talk about making a life cycle assessment, we take everything into consideration, from the extraction of the raw materials, the transportation to the production facility, the manufacturing of new building products, transportation again to the construction site where we erect the building. And then of course we have a long use phase where we need to operate and maintain our buildings. Perhaps we need to replace some of the building components. And at some point we may need to retrofit or disassemble the building, where we can also either recycle or reuse some of our materials again. Throughout Europe, we've had a very narrow focus in many years on energy performance of our buildings, on the operational energy use. And what I see in especially the UK, you've started to also have a great focus on the upfront carbon emissions from your buildings, where especially, of course, also structural engineers can make a huge difference. And when we talk about whole life carbon, we need to, of course, include the entire life cycle of a building. So both the upfront carbon, also the embodied carbon during the use stage when we maintain, repair and replace the materials, and also the end of life carbon when we deconstruct, transport, and also the waste processes and the disposal. So when we talk about the whole life carbon, it's both the embodied carbon and the operational carbon. And it's based on this European standard, which sets the calculation rules for the assessment and is intended to really support the decision-making process and the documentation of a life cycle assessment. I won't go into more detail with that. But what we see is you can really use the whole life cycle carbon or whole life carbon assessment during all design phases, and also from both building products to building elements, larger buildings, infrastructure projects, or even city areas. But of course, you need to work with it in different ways depending on the type of project and also in which project stage you're at. So I guess many of you have seen something like this or variations of it, that we have a lot of design freedom in the early phases. But as you go along and you decide more and more, it will increase the project cost if you need to make design changes. And what we've seen in the last couple of years, maybe 5 years, especially here in Denmark, where we've been working with DGNB, where a life cycle assessment is mandatory to conduct. Oftentimes it's only conducted at the very later stages when we have a lot of information, because we of course need a lot of information to conduct these assessments. But what it then really is just a declaration of the carbon emissions. It will grant you some credits in the certification system, and you may be able to use it in the CO2 accounting, but you can't really make any design changes at this point. So what we're really trying to do a lot of the time is move these whole life carbon assessments to the earlier design phases, where we can actually enable an informed decision making. That is of course difficult when you don't have a lot of information, but there are various ways to work with it anyway. So for example, in the very early phases in the strategic definition, you may not have any real quantities, areas even, but you will probably know what type of building you're going to you want to build, and for that you can set targets. And I can see that in UK you both have the Reba and the Leti they've come up with some suggestions to potential targets that you can set for a building. If you're a large engineering or architectural consultancy, you may also have your own benchmark database where you can look at what previously an office building at a certain size, where it would end CO2 emission wise. And in that way, be able to set some either ambitious targets or just normal targets for this building. Then, of course, you can also use a whole life carbon assessment in a sort of a screening way, that you ensure you meet the target, even though you don't know a lot about what materials are going into the building at a certain, at this very early stage. You may be able to use standard building components that you are traditionally using, and then start out with that, see if you're able to meet the target. If not, then proceed with optimization. In Denmark and also in other countries, it will become a requirement that we need to hand in a whole life carbon assessment for building permit. I'll get back to that in a moment. So in 2023 in Denmark, we will have to hand in such an assessment to even obtain a building permit. So of course, we would then need to know if we can meet the targets that are set. And during the design, we can make comparative whole life carbon assessments, comparing different solutions to each other, and in that way make informed design decisions. That can not only be on carbon, it could also be on cost, on energy, on many various aspects. And then, of course, we can use the whole life carbon assessment to also know what we should specify. That could also be that we want to specify that the materials used in the building, they have declared their carbon emissions. That could be something like EPDs, environmental product declarations. Yeah, and then, of course, in the end, we'll have a final reporting ensuring that we're meeting national limits or the limits set by the client. So now I'm getting back to the regulation across Europe. As I said, in Denmark in 2023, we'll have national legislation in our building requirement that we need to conduct whole life carbon assessments for all new buildings. And for buildings above 1,000 square meters, we need them to also apply to a certain limit that we cannot go above. And actually, we see the same picture in many of the European countries. You see yourself, UK, you have a local legislation, we've called it here, for the Greater London area, which was introduced in 2020. So there are various ways of introducing this across countries in Europe. And what I'm about to say with that is, here in Denmark, I've just listed the limit values that we have, and you may find them hard to translate into what makes sense in UK. And also it's really not something that you should do, because, for example, in Denmark, when we calculate the square meters of our buildings, we also take into account the outside of the walls, where I believe you're on the internal side of the walls, of the outer walls in UK. So when you have a limit value, which is per square meter, it will be completely different. And some other things that are also different across the countries is that the different countries actually also look at different life cycle modules. So even though we all have the same European standard, it's not all countries that are focusing on all the life cycle modules, because some of them can be quite hard to quantify and we don't have a lot of data for it. So that's also another reason why it can be difficult to compare between the countries. Similarly, now we're talking about carbon emissions, but actually also in a lot of the European countries, Denmark, France, Germany, the Netherlands, we are not only to report on carbon, we also to report on a lot of other environmental impact categories. Yeah, and in France and in the Netherlands, you can see I have put some more dots because they actually report on even more impact categories. Of course, the focus is often on global warming potential, and so it also should be. But we do see an increase in clients also asking us to specifically report on reductions on some of the other environmental impact categories. Then I have a short case on refurbishment versus new build, because this is one of the this is like some of the cases where it can be really important to look at whole life carbon assessments. So often we have clients that wants to justify a new construction. They say like the existing building and a minor refurbishment, it will just have a lot of CO2 emissions over the years, whereas if we do make a larger retrofit and a new facade, we can then decrease the emissions over a 60-year lifespan. And they say, well, but a new build will be a lot more efficient and therefore even lower CO2 emissions. But it's often really not the case. So actually the retrofit, including new facades, can often be in the long-term perspective, a better solution. But this is something that you can explain and look into in the specific project. So here is a specific project from Denmark. It's a retrofit versus new build. And here you can see 3 different types of renovations. So first renovation, we're only renovating the roof. In the next one, we're renovating the roof and the envelopes, so the facades and the windows. And in the third one, the pink one, we'll renovate the roof, the envelope, and the installations, also changing the heating system to, for example, heat pumps. And then there is the new build solution, which is the light blue one. And here you can see that the renovation projects will all have very low upfront emissions, but of course higher emissions during the lifespan, depending on how efficient the building is. Whereas the new building will have large upfront emissions, but of course high efficiency in the energy performance during the lifespan. So this is a way that you really need to take into consideration when does the emissions occur over the life cycle. So even though we may look at the limit values that are after the 60 or the 50 years lifespan, but we also need to consider when do the emissions actually occur. And of course, always assess within a given context, because this can change. And we do also see some projects where it perhaps will make sense to build something new. And this is also a new building according to the standard building regulation that can of course be improved also tremendously if you design for it. So collaboration is key in this. And we often talk about the sustainable frame, the sustainable roof, the sustainable place, and the sustainable human. And it is important that we take all this into consideration when we design our buildings. And there are a lot of things to really take into consideration, both cost, material availability, especially now. I don't know how the situation is in the UK, but in Denmark, it's really, really hard to get materials, sourcing distances, aesthetics, and these sort of things, and really have it all come together. And one thing I didn't have a lot of time to talk about is, for example, something like circular design, which is something that we also, it might not benefit us here and now when we are designing our buildings, but we also really need to consider how we can design so that we can use our buildings as material banks in the future, making sure that we're able to continue to simply directly reuse building components. I think that was it for me, and I think I just managed to do it within time. So thank you very much for listening. Yeah.
Fantastic. Thank you, Christine. You're right. That was bang on 15 minutes. Well done. And I hope that you can join us next week for day 2, because you touched on circularity at the end there, and we're going to have a whole 15-minute session from Penny Gowler on that in more depth. So hopefully you can come along and listen to that. Thank you, Christine. So we're now going to hand over to Susan Mckenzie. Susan is a senior structural engineer at Arup. She works as a design manager and engineer across a number of projects, but is also working with Arup's global sustainable development team to look at the topic of carbon targets more widely. I mean, Arup is a huge firm, so that's quite a big conversation, but it makes her quite well placed to come and talk about carbon targets on all sorts of levels which I think is the first place people usually get stuck. So looking forward to hearing about this. Susan, over to you.
There we go.
Yeah.
Jumped over to the other screen. I couldn't find the button. What a start. So yeah, apologies about that. I think it might be a tough act to follow as well in terms of timing. So yeah, I'll do my best on this. So Susan Mckenzie, design manager at RF, but previously worked as a structural engineer. It's great to be joining this conference. I'm following the talk so far, and today I'm going to talk to you about carbon targets. I think it definitely follows on quite nicely from some of the talks, especially Yannick's talk. So I'm glad I didn't have too much overlap on that, but I'm going to talk to you, kind of zoom out a bit and look at high level carbon targets, and then zoom in a bit to project level carbon targets, and then a bit about setting targets, and then just to wrap up. So on the high level carbon targets, so on the left hand side, I've kind of summarized various different organizations and initiatives that have set out kind of built environment, so kind of broader vision targets around net zero, so halving global emissions by 2030 and net zero by 2050. So I think we all are aware of those and all of the different acronyms below there, which are pushing for those, and all have kind of different parts to play. And then on the right hand side, some of them the more specific built environment ones, not too specific, but basically by we're looking at trying to get all new buildings to net zero in operation, and then all new buildings, infrastructure, renovations to have at least 40% reduction in embodied carbon by 2030. And then by 2050 at the latest, all new and existing assets to be net zero across the whole life cycle. So just as a reminder, and most of you will be aware of the IPCC, but this is where it's all coming from. So the Intergovernmental Panel on Climate Change stating what temperatures we need to limit to, and just a graph there to show that we have a long way to go and substantial cuts to make, and rapid and far-reaching changes are needed to get there. And just to pick up one of the things there, so 40% of the buildings and 75% of infrastructure that are projected to exist in 2050 have yet to be built. So just to show the scale of what we're dealing with here. Yeah, in terms of the built environment and buildings kind of targets. So within the UNFCCC, there's the Marrakesh Partnership, which was launched in 2016. And that is responsible for setting out the climate action pathways for how we get to a 1.5 degree Celsius resilient world. And one of those pathways is the built environment one, which you can see on the screen here. It's a really interesting report actually, and the table here sets out the milestones to 2050. And just to plug out some of those things, so by 2021, companies right across the built environment value chain should set out their net zero commitments. And then by 2030, so the same kind of targets again, so having built environment emissions by 2030, all new buildings net zero in operation, and all new buildings, infrastructure or renovations to have at least 40% reduction in embodied carbon, and 50% for leading projects. And then by 2050, all new and existing assets to be net zero across the whole life cycle. And again, just in consensus with that as well is the World Green Building Council, which is a non-profit organisation and global network of national green building councils, which was founded in 2002. And there's two elements to the World Green Building Council work, two key elements around net zero. So they have the net zero carbon buildings commitment, which was just updated recently to include embodied as part of the commitment for 2030. And that's just shown on the screen. And then just in agreement with what's been set out by the UNFCCC, they have the whole life carbon vision, which again is 2030 and 2050 targets for net zero. So then just to look at project level targets. So as we've heard this morning, there are a number of different pathways, reporting frameworks, and different target initiatives, which have set out what to do on projects. And so it was really useful to listen to Yannick's presentation on that in terms of legislation and policies around this, and how it's different countries, and it's also moving very fast. And also Christine's presentation just showing some of the European targets as well. And I've just got a snapshot of a few to talk through today. And I guess it's just sort of signposting some of these things for people to be aware of and to delve into, to help then with actually setting this out on your projects. So just to jump in, so we've got the construction declares, which is something that most architects and engineering firms and contractors have signed up to. And in that, there is a commitment to minimise whole life carbon on projects. And one of the objectives set out by the UK Structural Engineers Declares was around whole life carbon modelling to be included as a basic part of scope. So just a reminder of that commitment that most of our companies and firms have signed up to, that we need to fulfil. And then there's the World Business Council for Sustainable Development. This is a bit of a test of all these different acronyms, who have proposed a new framework that can be used as a common language for carbon emissions by all actors of the built environment. And just recently they published this report with some colleagues from Europe, which is really useful. Look at 6 case studies that look at whole life cycle assessments and look at the challenges and the barriers and opportunity around this in the industry, and looking at carbon footprints. So it's a really useful report and really great in terms of actually looking at some numbers, which is always of interest to engineers. So I recommend having a look at that. And just to pluck out one of the findings here around some of the studies that they did at looking at embodied carbon targets, which put a 2030 target of 600 kilograms of embodied carbon per metre squared. Now that was based on gathering some benchmark data around a baseline case, which came out at about 1,000 kilograms of embodied carbon per metre squared, and then taking that down to the 40% reduction. But the report actually does then question, whether this is ambitious enough, and actually the fact that we do need to have more data to be able to set these benchmarks and targets for ourselves and continue kind of research and innovation in this space, because no one can definitely say right at this moment in time exactly what the target should be. It's definitely a work in progress, and I think it'd be interesting to see kind of where we are next year in this space. And then just to touch on some of these are quite UK focused, just to touch on the Reba 2030 Climate Challenge, which is a series of voluntary targets to reduce operational, embodied and potable water. The targets are provided for 2025 and 2030 for different types of buildings. And the suggestion is that targets that should be set for buildings should be looking at the 2025 targets as a minimum today, but trying to reach for the 2030. And that's because they're actually based on those buildings being in operation. So buildings that are being designed now should be looking at those targets. And then there's the LEDI, so that's the London Energy Transformation Initiative, which is a network of built environment professionals who have been looking in this quite amount of detail and working with a number of different industry groups to try and get alignment on this, because this is absolutely key. So we need alignment on the definition, scope and measurement methodologies and targets to help the industry move forward with this. So they've actually produced a suite of documents which provide guidance and definitions. And I think Yannick actually shared this earlier. So it's really helpful, and it's definitely good kind of suite of documents to refer to. And just to point out the diagram on the right here showing that the current average building design is sat at around an E in terms of their rating scheme, and that we need to be shifting that peak to A to reach the LEDI 2030 design targets. So we definitely have a lot of work to do. And then, of course, the I-D scores, which is another rating scheme which focuses specifically on the A1 to A5 emissions of the primary structure. And as Will mentioned at the start, definitely needs to be looked at in with the guidance on how to calculate embodied carbon, because this helps then outline what the calculation should include and exclude. And then you come out with a rating that can be compared then with some confidence that you're actually looking at these things in kind of good comparison with the rest of the industry. So this can be looked at in terms of an option, full asset or portfolio of work. So it's a useful way to compare different options. And then finally developer targets. So as Steve actually mentioned before, many developers are setting out their own targets around whole life carbon, but also embodied carbon. So these are just two examples I've plucked out here to show that developers are setting these out and including them in their brief. So something to be aware of, that you may be asked then to fulfill this, or as Steve said, go even lower. So, they're setting targets, but it's important that we are hitting the best we can with the design solutions that we come up with. And then also it provides a good starting point for clients that maybe haven't got like their own targets, is to look at what's out there already. So some thoughts on setting targets and carbon actions that we can take. So at a high level, so working with clients, making sure we encourage them, if they have been living under a rock for whatever reason, to acknowledge and adopt the guidance that is set out by the IPCC, UNFCCC and Global ABC. Encouraging companies to join the Science Based Targets Initiative and set science-based targets. And then encouraging owners and developers to sign up for the World Green Building Council Net Zero Carbon Buildings Commitment, or for various clients, encouraging them to sign up to the Race to Zero. So I guess a lot of companies will already have ticked a lot of these boxes, and just to say that maybe it could be a useful starting point for kind of conversations on more specific project targets, to see where they have made commitments already, and to see whether you can use this then to start the conversation if you can see that they are signed up for these things already, just to help then kind of remind them of their commitments and then push it through on projects as well. And then I've just set out an example of a roadmap for setting out embodied carbon targets on projects. So firstly, looking at setting an overall target. So using industry guidance and relevant schemes. So Reba, LEDI, developer targets, or depending on location, looking at other things, other benchmark information that's out there, and setting then the appropriate target for your building type and location. And then looking at splitting that up into the constituent elements of your project. So working out a percentage total carbon for each discipline involved, and then working out the carbon for each discipline, and then coming back and collating those, and then comparing with the targets that you set, and then revising and agreeing a carbon budget. And just to say that this process could be quite iterative, and it's actually just working it through with your client to actually make sure that what you set is reasonable and is actually pushing the limits and trying to do something innovative where you can as well. And then finally, just a little bit about action that we can take around carbon. So measure, track and reduce. So I think we've still got a long way to go in terms of figuring out exactly what we need to be doing around targets. But we should be measuring, because you can't manage what you don't measure. And the more information that we have from measuring carbon on our projects, it will help to develop better benchmarks and targets for the industry. And then just on whole life cycle carbon, so like Christine talked about, we need to understand the full impact of buildings and work together as an industry towards reporting whole life carbon as a norm. And then advocate for policies and standards. So in most countries, the policies that regulate or drive net zero carbons in the built environment are severely lacking, as Yannick mentioned at the very beginning. And more than 2/3 of buildings are constructed between now and 2050 are expected to be built in countries that do not have any building energy codes. So just around that, just doing what we can to influence policies and standards and then putting into that with the knowledge that we have. And then encouraging clients and colleagues to take action. So I think a lot of the people here on the call today are probably of the mindset already that this is the right thing to do, but not everybody's in the same space. So just doing what you can to educate others and strive for carbon measurement and target setting on your projects. And that's it. I think I'm okay for time. I have a summary slide, but that can be there for the pack.
Perfect. Thank you, Susan.
Thanks.
What's really interesting about the talks we've heard so far this morning, and your one captured a lot of that in one place, was how much progress has happened in the last year on understanding the numbers side of carbon. I mean, last year there was talk, we need to work out what business as usual is. We need to work out what people should be committing to in terms of targets. And today so far we've heard Grosvenor talking about 50% by 2030. Targeting 500 kilos of carbon per square metre. The Outlook report was showing 600. The Letty-Stott shows 600. The IPCC, UNFCCC are all calling on 50% by 2030. The numbers are never quite the same, but they're always in the same order of magnitude and the same level of ambition. I think that's a really important message that people can take away, is that, there is real progress happening on this. And whilst we might not have all yet agreed that we need to be targeting X by this date, we're all pretty agreed on what the ballpark is. And if you're working on projects that are doing something different, then you can raise that with the client and say, well, all of these people are saying we should be doing this now. How do we get there? So thank you, Susan, for trying to you summarize all that really well in one pack, I thought. We've got just over 10 minutes for Q&A. I wanted to ask one of Christine first, because Christine, you spoke a lot about collaboration, and if we then think about what Susan's just been saying around targets, I'm keen to know your thoughts around what advice you would give to structural engineers who want to set carbon targets, but where the rest of the project team isn't yet talking about this, Christine. So what advice would you give to the engineer who's out there, who's maybe the sort of lone wolf in the room?
Well, I think just keep pushing, keep asking the question, shouldn't we have a carbon target for this? I think I see a lot of the times that it's actually one of the team members that are the one really pushing for it, and in the end the client sees, well, of course we should have targets, and it may not be the structural engineer, it could be also the architect or the HVAC, but oftentimes it's just one person that is really keen to get this through, and often they succeed as well.
And Susan, do you have any thoughts to add to that as well? Because you must have been in this position at least once, right?
Yeah, definitely. Yeah, I think it's pushing it through and keeping asking the questions about what are we doing on our projects and how are we tackling this, and I think the absolute key is to be measuring it and then understanding it better, because we are starting to converge on certain things, but I think it's not fully there, and it isn't at the forefront of everyone's minds, but I think because such rapid change is needed, it will start to be. And like I said before, it will be really interesting to see where we are this time next year with this conversation.
Yeah, no, I agree. We've got a good question for Susan in from Ian Poole, who's asking about more granular targets, so sub-targets within targets. It's all getting very confusing, isn't it? But he's talking along the lines of, do we need KPIs such as material carbon factors to have reduced by a certain amount by a certain date? Do we need lean design targets to reduce material quantities by a certain date? Are these sorts of things you've been talking about, or are you still focusing on the big picture of where that gets you, what number you need to get at the end of it?
I think it's definitely because because this is a change in the industry, that we have been able to measure this for years, but we haven't been doing that on other projects for years and collating that information. So I think we're still at a point where the benchmark information maybe isn't quite good enough to be able to go right down to that granular level to hit those KPIs, but that is where we need to go. And I think the only way we're going to be able to do that is if we are consistent with measuring this on all our projects and aiming for that whole life cycle measurement on all projects, so that then we can then pluck out more information and more kind of detailed targets for where we're trying to get to. But because this is a shift in actually how we look at our projects, it's difficult to say, because you try and start gathering the information and it's still sparse. So that makes it hard then to actually be confident in exactly where things need to be in terms of KPIs.
I think the sort of important thing there is that you end up with lots of incremental change across a lot of different aspects. So there's material usage, there's how you make materials in the first place, there's how much retrofit you do instead of new build, material substitution. The resource I'd point people to on that is do go and check out the UK GBC's whole life carbon net zero roadmap, which I can put a link in the chat afterwards. It's currently been released for consultation. The consultation is closed, but the document is still downloadable, and the final version will be released during COP. And the way that worked was to get different teams of people to look at these different aspects. There was a team of people who just went and looked at what the cement industry is saying will happen to the emissions of cement between now and 2050. Another one looks at different materials. There's a team looking at design efficiency, a team looking at refurbishment. And that starts to sort of paint up a bit of a picture of how those things could combine together to get us towards this end goal. So yeah, I'll put a link in for that afterwards. We've had a couple of questions around materials, and rather than pass them on to the speakers, I'm going to ask, so Mike Pollack, who asked around steel and concrete, and somebody asked a question about absorbing carbon from the atmosphere, which I assume is a timber question. Do check in next week. When we do day 2, we're going to have a session on steel, a session on concrete, and a session on timber, where I think we'll go into a lot more detail on what you can and can't do with materials to get some low carbon outcomes for the planet, not just for your project. So I'm going to park those for now, but don't think they're not interesting. Please do just come back in next week to talk about them. We've had a question. It's quite a specific one for Christine, but I think it's quite a good one to talk about, around the Danish targets being set in kilograms of carbon per square metre per year. Whereas in the UK, we've always talked about, at least on embodied carbon, kilograms of carbon per square metre. Ellie Marsh said she's not seen the per year edition before. Is that based on an assumed building design life, and do you just divide by that? Do you go more granular than that? Do you look at how the energy grid might decarbonize, say, in the next few decades?
Exactly. Yeah, that's what we do. So the 50 years is not the design life, but just the reference period that is decided in the methodology. And it is annualized. And yes, we do consider that our Danish energy grid will become greener over the years. So that is also taken into consideration when we do the whole life carbon assessments. And we do often provide the results both in per square meter as you do, but also then in per square meter per year. That's also how the limits are set for Denmark for now. And I don't know why exactly, but that's how it is.
Yeah, that's useful. And we've had a couple of people asking, and they're kind of both based around asking for data to be shared, Christine.
Yes.
So we've had one person saying, can you point people to any data you have on larger buildings, because you put up some data around new build houses.
Exactly.
And another person asking a question around you showed a carbon graph of fit out options, which I thought was quite, and I hadn't seen that before either. Are these things publicly available? Can you share links to them? Is there anything we can share with people?
I think there was a link in this slide, but of course it's to a Danish report. I do think that some of the graphs in the report are readable, even though it's in Danish. And actually, we did make an English summary, so I'll try and dig that one out so that you can have the summary of the report. In that report, we looked into 16 different cases, and 4 of the cases were big office buildings, so they were above 25,000 square meters, so rather large buildings as well. And we also did look into life cycle cost for all the 16 buildings, trying to figure out how the cost would be. And that calculation of the life cycle cost is then based on the methodology that we use in the DGNB system in Denmark. So it's just to say that not everything is probably covered in that, but it's just using that methodology. And almost all of the cases also showed that the retrofit would be better for the life cycle cost of it. But of course, there are a lot of things that we could not take into consideration. Perhaps something like the cost of handling hazardous materials in a renovation perspective. That was not part of it. But I'll see if I can find the summary for you guys so that you can read that. Otherwise, there's a link for the Danish report.
Yeah, perfect. Thank you. Maybe we could get you to, if you can find a link for it, you could drop it into your slide pack, so that when we then distribute slides afterwards, people have got it in the right place.
I'll do that.
That'd be good. We also had a question earlier on from Dr. Jawed about, I'm looking at the wrong screen, from Srikantha Mithra, about calculating carbon from energy usage. So, I know my colleagues in the UK who look at energy usage a lot are very quick at then translating that into operational carbon emissions. For people working in other parts of the world where maybe there isn't already local guidance on this, are there places you could point people to where they can get from the substation that they're designing, or the lighting system that they're designing, and get from energy usage to carbon emissions? What would you say to people who are stuck trying to do that in parts of the world that don't have that sort of codified in country yet? feel like I might have stumped you. It's a hard one, isn't it?
Yeah, well, because if you don't have a national methodology, of course you can use the European methodology, but then the problem can often be that you don't have access to data really for the embodied carbon of materials. So I do see the challenge. In Denmark, we did not have a lot of data for materials. It's only just something that we've gotten now. So we've been using the German database. So like sometimes you can also use like other countries' methodologies and data just as a best solution here and now.
Yeah, and I guess the same is sort of true if you're looking at operational and you're looking at energy, right? You know, if you can look at how another country approaches it, and use their way of doing this as a starting point, that's probably worth doing. The thing to be aware of with all of this, whether it's embodied or operational, is trying to understand the difference between what happens in that country versus your own. So what is the energy grid in that country versus your own? You know, if that country is reliant on coal and all of your power is geothermal, you're going to find that you have a very different amount of emissions per kilowatt hour of energy. Similarly, if you're creating bricks from scratch in a country where the methods used to make bricks are just very different to the country where you've got a brick EPD from, again, you can usually pro-rata things, and you can usually sort of start to get an estimate.
Yes.
Yeah, so I think I agree with you, Christine. This is about just trying to see what other people have done and try to work out how you could use that. Yeah, it is a tricky one, sure, but something which will over time become less of an issue as more countries around the world sort of pick up on this. So I'm going to last question now, which I'm going to direct to Susan, which is sort of fairly related in a way. So you touched on the fact that actually most of the growth of construction between now and 2050 will be built in countries that don't yet have carbon being thought about. I mean, we're still at a fairly sort of infant stage of doing it, even in the rich parts of the world. What are your thoughts around how you help other countries to work in a way that helps them to avoid the mistakes that we've made in UK, Europe, USA over the last 150 years? Do you have any thoughts you'd want to share on that?
Yeah, I think it's a really interesting point to pick up on, because like from the sort of facts and figures that are out there, it's mostly going to be construction in Africa and Asia as well. So it's just to make the point, like to start thinking beyond, maybe if you are just working on projects in the UK or in your country, and thinking what else could we be doing and how else can we tap into that. I don't have any specific answers, but I think it's just to pose a question to people that the problem is much bigger than kind of at home. It's thinking about like how we can apply kind of our knowledge and experience at scale and kind of share that with others as well, and kind of tapping into like how we can influence policies elsewhere with the work that we've been doing here, and kind of making sure that the influence does reach across, and kind of then work being done on materials, and kind of looking at things like bricks and actually seeing, okay, how can this be applied in Africa, or how can we share that knowledge? So no exact answers, but it's just a point to sort of then spread kind of our thoughts and awareness to how we can help tackle it as a global issue.
Yeah. So this is about collaboration. It's about sharing what we've learned. I think it's probably also, I mean, it's always worth touching on the fact that as well, if we've worked out how to do something in a more low carbon way in London, that doesn't necessarily mean it's applicable anywhere else in the world. Before you've even left the UK's borders, there's lots of places that are not applicable. So I do think we have to be cognizant of the fact that you probably need a different set of solutions for Uganda to what you need for York in the north of England, and it's different again once you get over to Dublin, which is not that far away. And somebody asked a question earlier this morning about low income countries and carbon emissions. So I put some information in there about nationally determined contributions and how the sort of pathway to net zero is different for different countries, and how we should sort of be mindful of that when we're designing. I'd always come back to that and just sort of ask people to err on the side of caution of assuming that all countries are going to decarbonise at the same rate, because they're not. And if you're listening and you're working in a rich country, we're going to have to decarbonise a lot faster than the average around the world. And so we do end up with these slightly different design drivers. Good. All right. Thank you, Christine. Thank you, Susan. That takes us to the end of the carbon section. We're now going to whiz straight on to our final chunk of talks for the morning, and actually talking about international, and we touched on Africa there briefly. There's a lovely segue because out of our three speakers, we've got Africa, Australia, and the UK represented in the case studies section. So first, I'm going to hand over to Rosie Goldrick. Rosie is a principal and engineering director of Mass Design Group. She's based in Rwanda, and she leads a team that seems to constantly be growing of engineers drawn all over from Africa and other parts of the world. She leads the design and construction of really innovative projects built throughout East Africa. And we've asked her if she'd come and speak to us this morning about the Rwanda Institute for Conservation Agriculture, which is probably the most sustainable project I can think of. So over to you, Rosie, and I hope you all enjoy what Rosie is about to share with you.
Yeah, thanks for having me today. As Will mentioned, I'm Principal and Director of Engineering at Mass Design Group, and I'm really delighted to be here today. I'm a structural engineer myself, and I really support the work that the iStructD is doing in this area to encourage us as engineers to be accountable. We are a non-profit design collective of architects, engineers, landscape architects, writers, filmmakers, researchers, and we represent 20 countries across the globe. But where it all started is Rwanda, and that's where I'm based. That's where we've been working since 2008, and I've been here for the last 5 years. And we believe that architecture is never neutral. It either hurts or it heals, and it's also never sustainable. It's either climate negative or climate positive. And so I'm sure everybody at this conference is aware of this. We need to halve our embodied carbon emissions by 2030. And as practitioners, we're entirely responsible for this 40% of emissions, and we need to be accountable. And so we need to understand half of what. So as Susan said earlier, you can't manage what you don't measure. And so internally, we've committed to taking stock of all of our projects over the last few years, and actually been pleasantly surprised that our average is already close to half of the global average. So we were surprised to see that projects we designed 10 years ago were already meeting these targets in some cases. But in order to actually benchmark ourselves, this touches on one of the other questions. We had to develop some of our own carbon coefficients. For example, the fired bricks we used were fired with coffee husks. Coffee is a big industry in Rwanda, so coffee husks are a big waste product. And European data or American data wouldn't have been particularly relevant for that case. So we developed our own carbon targets. And if you do want to know a bit more about how to do this, my colleague James Kitchen, he wrote a good article recently in The Structural Engineer about how we went about it. So how was it that 10 years ago we were already meeting these targets? When we designed Butare Hospital, which was back in 2008, it was in an area that didn't have electricity yet, and yet there was an ambition to build a state-of-the-art hospital. So the resource limited context in this case actually took care of the constraints, and the principles that govern the design as a result were mainly local fabrication. So local materials such as volcanic stone, which was a local waste product as this is up in the volcanic region, and local labor. And this is how we inadvertently at the time achieved half of the global average in embodied carbon. And this is a project that's been celebrated in the New York Times, but its creative design is actually born out of lack of resources in part. And so more recently, and this is what I'll spend a bit more time talking about today, the Rwanda Institute for Conservation Agriculture is a project where we achieved less than half. It's a 20,000 meter squared institution. You can see here it occupies a huge site of 1,500 hectares, and it's dedicated to training a new generation of leaders in conservation agriculture techniques that promote sustainable food production. And the project was conceived and funded by the Howard G. Buffett Foundation, the government of Rwanda. And this is what the Institute is really trying to achieve. Rwanda is the most densely populated country on the continent, and the population is going to double by 2050. So we're going to have a huge amount more construction and a huge number more mouths to feed. And yet, over the last 30 years, the landscape has changed from forests and savanna to mainly agricultural land. And yet there's still food insecurity in the country today. So how will the growing population be fed? And how can this be done without clearing more land, generating more loss of species and more diversity? Agricultural productivity is already declining wherever there is lack of diversity, and it will decline further due to climate change.
Rosie, we're having trouble hearing you, so maybe if you turn off your
Inextricably.
camera, that
You want me to turn off the camera, yeah?
yeah, I think it might just help keep the connection for your voice a bit better.
All right. So the design was a collaboration between MAS and Arup. MAS were responsible for the architectural design and building services and overseeing the construction of the campus. Arup did the civils design, and the structural design was actually a collaboration between MAS and Arup. And this is actually a project that Will and I worked on together. He was seconded to us from Arup at the time and led a lot of this design. And so the campus is completely off-grid. We've got a solar array which produces 100% of the electricity, and it sources and treats all of the water on site. And the structural design brief for the Institute demanded high quality buildings that really stood the test of time. We had 69 of them to design over a very short period of time. And so we had to work very closely with the architects to manage the design principles and also apply the principles of local fabrication at scale. But just something to be aware of, Rwanda is seismic, and so we had to follow the Eurocode guidance for structural regularity very closely, trying to create symmetry in both directions, adding movement joints where necessary. And this allowed us to design many of the buildings quite quickly using the lateral force method. And there was a few feature buildings that we did modal response spectrum analysis on. So following on from the ethos of the campus in terms of conservation, we were really interested in designing with earth, particularly having the benefit of a large site. And so the way we approached this was to carry out upfront testing of earth as a feasibility study for whether we could really do this. And this is my colleague Amab, who spent a lot of time preparing samples of different soil sources with different stabilizer quantities, and this data informed our design process. We also investigated sustainable sources of timber regionally. We were really excited that a new company had just set up in the south of Rwanda, a mill called New Forests. And so we discussed the timber member sizes with them. The maximum length was 4 meters, which was based on their kiln size, and the maximum depth was 200 millimeters, which was based on the fact that the trees were fairly small. And there was no engineered timber, but we still wanted to be able to do fairly long spans with solid timber. So we used this data to define the structural grid. So we developed a 8-meter spanning truss, which was made of 2 4-meter pieces, as you can see here with the joint in the middle. And the grid was therefore 8 meters with this truss by 4 meters in the other direction. And the truss shape also allowed a lot of daylighting into the learning spaces through a clear story. So generally the materials for the project were ceramic roof tiling fired with coffee husks, timber roof structures, and earth walls, either rammed earth or compressed stabilized earth blocks, and stone foundations. So it was really a dream project for me as a structural engineer, but of course designing with natural materials is not without its challenges. In order for us to use them, we need data to design with. So for earth, we collected this during the feasibility study. For timber, however, we were perhaps too theoretical at the start. We worked with our partners at Arup, they're timber experts, and we worked with the mill. So the mill didn't do any kind of visual or mechanical grading and had no test data to date. So we took the species and the density, and we looked at reported data from other forests worldwide with that species. And then during construction, we trained the mills and the contractor to carry out visual grading. But we found that we were getting a huge rejection rate of about 70%. And it was mainly due to these knots, which come from branches. So the forests in Rwanda and in this region have not been managed consistently. And the strengths we assumed were based on managed forests. So we find that here we've got a lot of trees where they haven't been pruned over the years. And so the branches are what causes the knots, and that leads to great variability in strength and a much lower strength generally. So in order to accept more timber, because a 70% rejection rate just wasn't feasible, we decided to carry out testing and define our own grade of timber specific to this project, which was based on the percentage of knots that would allow for a reasonable acceptance rate. And it did turn out to be weaker than expected, mainly due to the variability. So what we learned really was that we should have approached this in the same way we approached the Earth, with upfront testing and making no assumptions based on information from other contexts. So this is one of the challenges in the industry, particularly here. Low carbon materials are not always easy to design or construct with because we don't have data. So we've got a great understanding of this now, but we were lucky to have the resources on this project to do this kind of testing, and it's certainly a barrier to others. But in the end, it was a success. We sourced 96% of materials in Rwanda, 98% of labor was sourced within 100 miles. And ultimately, we achieved a 58% reduction in the embodied carbon compared to the business as usual approach. And it is worth this investment in upfront material testing. This is where we need to be headed. And despite the challenges, we actually have no choice. As engineers and architects, we need to be creative in the use of local materials. And whenever there is data that's lacking, we should seek to create it rather than see it as a barrier. And this ethos was applied throughout the project to the furniture, fixtures and fittings as well. So this is Rolaris making the tiles. All of the light fixtures were made in country. The metalworking was done in Getchinjuru. The banana weavers made all of the sofas to really high quality. Our FFE team went out touring the country at the beginning of the project to find all of the makers. So this is great. This is how we got to half or just less than half. But how can we get to zero, and how can we get to carbon positive? And really, that's around conservation, restoration, and regeneration of landscape. So we calculated the embodied carbon of all the buildings and infrastructure on the campus, and we developed a purposeful reforestation plan along with Rika, which allows the project to be climate positive before 2040. So removing more carbon from that point forward than was produced from the campus's creation and ongoing operations. So it's actually projected now to be the first climate positive university in the world. So what's next? In order for the market to expand, as structural engineers, we need to be able to easily design and specify these materials. So the supply chains need to be strengthened. The mills need to be supported and required to produce sustainable, treated, graded, tested timber to allow it to be more widely used and in a standard set of sizes. And I know that some of you are curious about the policy side of things. The government Rwanda are also developing policy and strengthening the supply chain of another natural material, the adobe block or mud bricks, which are associated with poor quality and sometimes dangerous construction, but they've recognized that many solutions are required to meet their current housing demands. So they've legalized the material and they're seeking to regulate it. So we've collaborated with the Rwanda Housing Authority, Rwanda Standards Boards, Rwanda Polytechnic, Earth Enable and Green Pact Africa to contribute towards research and drafting of these standards, which will inform the regulation. So I think that's all we have time for today, but thank you so much for having me, and I hope the sound got a bit better.
Yeah, no, it got much better, don't worry. Thank you, Rosie. Really good as well. I've heard a lot of people talk over the last couple of years about the need to fast track R&D into practice. And I think that, what you just described there around getting timber to work in a country where timber grading didn't really exist, and getting earth to work in the same way just sort of exemplifies the routes we need to go down to if we are going to use new materials, novel materials, low carbon materials. So thank you for sharing your insights on that. We're going to move now on to Lachlan, Ramsey and Richard Fagan, who are joining us from Australia, where it's now about 8:30 in the evening. So thank you, both of you, for giving up your evening to join us. And a completely different scale, again, of projects. They're going to introduce the Ballarat Gov Hub building, I hope I pronounced that right, which is one of the few mass timber commercial buildings in the country, and one of the first where the local ACON team was sort of challenged to start running through carbon figures by the client. So I think, again, there's going to be a lot of different stories to learn from this project, which is why we asked them to talk today. I'm not sure which of you is going to go first, but whichever one it is, over to you.
Thanks, Will. I'm going to start off. My name's Ricky Fagan, and my co-host Lachlan, Ramsey, and I will be talking about the embodied carbon calculations we've been undertaking for several selected structural projects at the ACON Melbourne office. I'm just going to briefly mention the carbon life cycle, which I know Christine discussed in more detail earlier, and our experience of calculating embodied carbon in the Australian context, and also some particular nuances we've encountered and started to consider when developing our carbon calculations. Lachlan's going to present our case study where we compared the embodied carbon of different structural schemes, and we also compared the operational emissions under various facade schemes so that we could understand whether an additional outlay of embodied carbon at the start would be paid back by operational carbon savings over the life of the building. So when we think of carbon emissions from a building, we refer to the Eurocode definition of a building's life cycle, which Christine mentioned earlier. As structural engineers, we often think of our influence as being mostly in the production phase. So how will reducing material quantities or changing the materiality of a building have an impact on the embodied carbon? But our decisions also have an impact on the use phase, which Lachlan will go through, and we'd also be remiss not to consider the impact of end of life, and that's particularly for timber, which I'll mention later on as well. So this graphic is from the London Energy Transformation Initiative. It shows the emissions split into embodied and operational carbon. For a typical building, the embodied carbon from construction and end of life might be as much or even more than the operational energy for the entire, say, 50 or 60-year life of the building. So we're expecting this contrast to be even more pronounced for the current generation of buildings, because as I think Christine mentioned earlier, there's going to be decarbonisation of the grid leading to a reduction of operational carbon year on year. You can also see the impact of elements requiring replacement there. So like at 30 years, you might replace the facade, which could result in a spike of embodied carbon. So when we talk about calculating embodied carbon of a structure, it's really as simple as calculating the volume of materials in the structure, multiplying it by the value of carbon equivalent. Obviously, that's not that simple. And there are standard databases for the A1 to A3 life cycle stages. So the amount of carbon that's been emitted in producing the material until it's released from the manufacturing plant. And then you've got stages A4 and A5, which we can also estimate, and that's to do with transport to site and during construction. And then you can get a fairly accurate picture of the start of life emissions. The calculation sounds simple once you've got this number and then you've calculated your volumes, but coming up with a carbon equivalent factor for a material is not that simple. In Australia, there's a few different databases which combine all the common construction materials. and they use an average value of carbon based on what's available in the local market. And as you can see, those top two numbers, the values can differ quite significantly. So a more accurate value could be obtained from the EPD, which we've shown at the bottom. But the issue with that is using an EPD might look like you're saving carbon if you get a really good product, but that locks you into a particular product. So early on in a project, you can't really do that because you're locking yourself in and your client might not go for that product. And carbon sequestration is another piece of the puzzle that we've been looking into. So that's the carbon stored in trees, which are eventually turned into timber, and it can count as a negative emission, so reducing your embodied carbon. Obviously, you know, it's not that simple. There's all sorts of caveats before you can start taking negative emissions. For example, most timber these days from demolished buildings end up in landfill. It decomposes, it releases greenhouse gases into the atmosphere. So how that's managed in your landfill makes a big difference to the overall embodied carbon of a building, and it's not something you can control during construction 60 or more years before your demolition. So you need to make realistic assumptions. And there's also the opportunity cost of the land where the timber's grown. If it wasn't going to be used for a sustainable timber forest, would the land be you know, a natural forest, in which case there's going to be some carbon sequestration already, so you can't really take credit for it all. Or, you know, has farmland been bulldozed to build a sustainable forest, meaning that neighbouring farmland might need to be more intensely farmed to produce the same crops, leading to more emissions elsewhere. So these sorts of things are difficult to estimate from a desk study and can have a big effect on the embodied carbon of a building. So I'll now pass on to Lachlan to talk about our case study.
Thanks, Ricky. So Ricky's given us a bit of an overview of how the process that we followed to come up with our numbers for this building. The Ballarat Gov Hub is a 5-storey building that's going to be used by the Victorian government, predominantly for offices, and it was completed in about March this year. And the interesting element with it is it did end up being built out of engineered timber products. So this project actually was a really good one for us to start with, and dipping our toe into the water, trying to understand this embodied carbon question, because we actually were engaged by the client to produce 2 sets of tender documents. So we had a really good starting point for measuring up to distinct structural schemes. So the first was a concrete scheme in which we use what we'd say a traditional concrete method of using in Australia of post-tension floor plates, and then in the timber scheme is a combination of glue laminated beams and columns, as well as cross-laminated timber floors. The process for us, I suppose, involved measuring up the quantity of the materials and then timesing it by that coefficient associated with the materials themselves, and applying reinforcing rates so we could actually get that full bill of quantities, and then we could come up with our number. So we went through that process, and effectively what it showed was that when we include the sequestration element of the carbon being sequestered into the timber, it showed there was around about a 30% reduction in the amount of carbon between the timber scheme and the concrete scheme. So that equated to about 2,950 tonnes of carbon. So what does that really mean in context for the building? Well, our building at this point in time uses around about 700 tonnes of carbon a year as average operating emissions. And that equates to about, so the number equates to about 4 years of operating emissions, which is, I think, quite significant, because you could easily invest a lot of money in improving your HVAC systems, improving your insulation, to try and find those savings through operational methods. And just to sort of put that into a bit of a layman's kind of terms, where I just compared it against my power bill in Victoria for a 2-person household. So it was equivalent of about 1,500 households being turned off for 1 year. And I think it tells just an interesting story there about the impact that you can have as structural engineers through your work can be far more important than the things that you're doing at home. So really, the time spent at work is very important. The next part of our study, we wanted to understand the relationship between improving the performance of the facade system and what improvements that has on the heating and cooling for the building, but what penalty you pay for going for those higher levels of glazing and putting more embodied carbon into the system. So we looked at the single glaze, double glaze and triple glaze units. Our study, I'll only touch on some of it for now, but we did look at electric building option and also an option that was a combination of electric and gas. And we also factored in this element of the decarbonisation and move towards renewable energies within the grid. So now that we use that same process that we did for the structure to come up with our number for the facade. And then effectively now we've got these structure and the facade number, and we wanted to know where we actually stood in terms of where we're sitting in comparison to other buildings. So there's not a lot of content for us that's Australia based, but we have sort of lent on the LETI, the London Energy Transformation Initiative targets, which have been spoken about by Susan and a couple of other people already. They also, so if you're starting out and trying to understand how to approach this, the LETI Carbon Primer is a really good resource, and I definitely recommend having a look through that. They've also got some guidance in there for just general rules of thumb about what percentage split should be between substructure and MEP and facade. So we were expecting to aim for a target of around 80 kilograms of CO2 emissions per metre squared of gross floor area for the facade and about 325 for the structure. So that's 405 kilos was our target for facade and structure. So the top figure there is actually the concrete-based scheme, and then the lower figure is the timber scheme. And you can see both of those actually fell underneath that target. And we expect that there may be some influence there due to the fact that we use a lot of post-tension concrete in Australia, which results in thinner floors and potentially quite a bit less reinforcement than just a reinforced concrete option. Maybe one of the reasons as to why that is a bit lower as well. So just the final part of our study and the final piece was unpacking and understanding that difference between the embodied carbon that was in the better glazing systems versus the performance over time. So this blue line that's shown on there is, you can see that it's sort of tapering off as it goes over time. And that's the effect of this all electric building and the grid decarbonising as we move towards our net 2050 targets. So that you pay that penalty by having a greater embodied carbon element in your facade system when you go from double to triple glazing. And you can see that but there is an increase in performance, which is actually lowering those emissions that you're emitting year by year. So there's a offset point of where you get to where that penalty actually pays off between the efficiency of the system actually taking over from the extra that you put into the system start off with. So for the single glaze units against the double glaze units, that point occurs at 6 years. From the single glaze to the triple glaze, that occurs at 9 years. But interestingly, from the double glaze unit to the triple glaze unit, which this building actually was upgraded to be a triple glaze system, it never actually offsets itself. The carbon in the system is always still greater under the triple glaze unit system. So, and when we ran other models with the gas and stuff as well, it showed like it was around about 25 years for that offset, which is around about the replacement period for a facade. So based off of Australian conditions and the heating and cooling requirements, if you're purely making your decision off of embodied emissions, overall emissions, then our recommendation would be to people is that double glazing actually is a better option, even though it's counterintuitive. So to summarize what Ricky and I have spoken about, I suppose it's been talked about already too, I think, is starting that conversation early, because the choices about the form and materials are often made at the earliest inceptions of the project. And it really is up to the structural engineers and the architects and the clients to really understand it, because the ASD teams often won't be engaged for potentially another, quite a few months and months later in the project. The embodied emissions in the materials often been overlooked in favour of focusing on the operational emissions, and there's a really large potential to reduce your whole life cycle emissions by focusing on this embodied carbon part, and we really need to be doing this. And that when we look at the overall carbon footprint of our facade system, sometimes the highest performance is not always the optimum solution. So I think that's probably around about our timeline, but I just want to say thank you for inviting us along to this. It's a pleasure and an honour to be asked to come and present and talk about what we've been up to in Australia. So I'll pass it back to you, Will.
Yeah, thank you, both of you. Yeah, really good to hear about the work you're doing. It's funny, isn't it, how, you know, you're on the other side of the world to me, but it is all of the same issues and all of the same thought process that we've all got to get through. And I just think it's worth sharing that with people from time to time. So thank you for presenting on my projects. Our last speaker is about to start. Our last speaker is Anna Beckett. Just before I move on to Anna, again, don't forget, write your questions in the chat as we go, because we're bound to run out of time, I think, given the projects that we're seeing presented to us. And I know that this last one's, you know, equally good as well. Again, a completely different project. Anna, who's an associate structural engineer at Webb Yates Engineers in the UK, she's going to present on York House, which is a refurb and extension project, so a bit different again. And we asked her to come along. It was one of the projects shortlisted in the structural awards under the Zero Carbon Ambition category. So we thought it was worth probably getting one of those awards along to speak. So over to you, Anna.
Yeah, okay, great, thank you. Well, yeah, first of all, thank you very much to Will for asking me to come along and speak, along with so many other people who are very much more knowledgeable about this than me. Yeah, the project that I'm presenting today is very different from the two projects that we've just had, but hopefully equally interesting. So yeah, this is York House, which is an office refurbishment and extension project that we completed towards the end of 2019. We worked on this project for the office group, working with DMFK as architects. It was a 1981 office building on Pentonville Road, so just near to King's Cross in central London. And at the time that it was built, it was one of the first office buildings built in this location. And I think there actually was quite a lot of objection to there being office buildings here. Other than that, there's nothing really particularly remarkable about the building. It's no particular historic or architectural interest. The only kind of slightly interesting thing about it was this sculpture, which you can see in the picture here on the end of the building, which was by an artist called Geoffrey Clark, which was protected, I think, and we had to make sure that that stayed as it was. So these are some photos from when we first started working on the building. At that point in time, it had been empty for, I think, 2 years. And yeah, as I mentioned, it was a 1980s office building, and I think it had basically ended up being empty because the spaces weren't really usable as modern office spaces anymore. It wasn't very well lit or very well ventilated, and there had been some deterioration of some of the facade in some locations. They'd also had a small fire in the basement at one point, and around the back of the building there was a lot of debris. People had dumped things there, and I think it had been used by homeless people quite a lot as well. So this is a plan showing the building. So Pentonville Road is running kind of across the top of the screen, and Lorenzo Street, which is the side street, is running down the right hand side of the screen. And you can see the extensions that we added to the building in the plan here. So we extended out at the front of the building towards Pentonville Road to create this kind of symmetrical extension that matched with the existing shape of the building. We added a new light well, which is to the left of the front extension. We added an extension at the rear, which is the kind of sort of grey bit at the back. And then we extended by a story at the roof level. And the front and the roof extensions are both in CLT. The rear extension is a combination of steel and timber. And then there also were lots of internal changes. It was completely refitted. It had new windows, new lifts and toilets to make it much more usable as a modern office space. So this is I'm sure the most inspiring photo that you've seen all day. This was the roof as it was when we arrived at this project, fairly typical of these types of buildings, with the space, it's just got gravel on top of insulation and a window cleaning rig around the edge. But I've included it because the roof wasn't designed to even take plant equipment. It was only really designed for very lightweight roof load. So one of the main issues for us extending on top of this existing building was that this roof structure couldn't really take very much additional load. And so making the rooftop extension lightweight was quite important when we started looking at this. And this is the existing structure inside. Again, a not very inspiring structure, existing concrete frame with a waffle slab. It's got some shear heads around the tops of the columns. But we did quite a lot of investigation works of the existing structure to work out exactly what was there and how we could use it, where there was reinforcement and where there wasn't, and how everything fitted together. And then also in this picture, you can see the facade is masonry all the way around with blockwork on the inside. So these are some photos of the CLT front extension during construction. One of the key things with this project was obviously persuading everybody else involved that CLT was the right answer. We originally proposed the idea of doing extensions in CLT to the architect because it made sense structurally to do that, particularly for the roof extension. Like I said before, we needed something that was going to be really lightweight. And the architect was very much on board with that. We then proposed it to the client. And when we talked to the client about it, we initially came with it as a suggestion because it would work for their spaces rather than because it was a low carbon solution. So we proposed it because it would be a warm internal space, it would look really beautiful, it would add to the idea of this being a more aspirational office space, and the fact that it was going to be good for the environment, it's going to be low carbon, was actually an added benefit to them rather than the main selling point for those extensions. And we also talked to them about how we could have these really nice details, like you can see here with the interface between the CLT and the existing structure. So you could kind of keep this play between the new and the existing, but create these really beautiful spaces. We also explained to them that we could make the CLT work for their requirements. So the slabs for the front extension are 300mm thick, which worked for the fire requirements. It also worked for the vibration without needing anything additional. And we knew from a previous project that with a 300mm thick CLT slab, we had done some testing. We knew that you didn't need any additional separation for the acoustics. So the CLT on its own could meet the acoustic requirements for this type of office building. So in the end, the CLT soffits could all be exposed. They have a coating for preventing the spread of flame, but other than that, they are as they appear in these photos. Similarly, for the roof extension, we again talked to them about how it would create this really beautiful space, that it would feel really warm and welcoming, and it was a really nice space for kind of well-being and enjoyment of the building. And that secondary to that was this idea that it was going to be also low carbon. And you can kind of see here that we use the CLT to span across the roof deck as a transfer structure, and then built this CLT box sitting on top of that. The contractor was a little bit more difficult to persuade. They were, as you would expect, worried about cost and also worried about how easy it was going to be to build. It's a very tight site. As I said, it's right on Pentonville Road, and obviously you can't close Pentonville Road to put in a crane to lift stuff onto the roof. We didn't really have very much space on the site where we could put a crane. It was difficult to get deliveries because, again, you can't block Pentonville Road. And we're also, the Northern Line is running below Pentonville Road as well. So there's quite a lot going on, and they were concerned about getting materials up onto the roof. They wanted us to change it to be just a steel frame. And so we worked through how you could actually build this. And in the end, what we did was installed the foundations and the slab for the front extension first, and then used that as a base for a crane so that they could then lift up the CLT onto the roof. And actually, because the CLT is so lightweight, we could lift it up in these bundles and we could store it on the roof for them to use, even though the roof had this reduced capacity. And obviously we had to suggest to them how they might spread that out and make sure we didn't overload any parts of the roof, but it all meant that it could much more easily be constructed within those really tight confines of the site. The front extension I've included, it's very much not low carbon, it's all masonry, but architecturally it's kind of the most striking part of the building. But I've included it because actually we designed it all to be freestanding. It's self-supporting, it doesn't have any additional structure behind it, whereas you might expect that this would have had some sort of secondary frame to support it, or it would have had some additional brackets. It doesn't. It has some reinforcement in it, but it's all designed to be self-supporting. And there was a lot of work that we did with this, with testing the bricks and making test panels to try and make sure that this all wasn't going to crack. We've used a lime mortar all the way through so that it has some flexibility and it can all expand and contract. And then the curtain walling for the building sits behind that and is supported from the edge of the CLT slabs. So the embodied carbon, overall, in the end, for the structure and the masonry, I think we had about 250 kilograms of carbon per metre squared. And then when we add in everything else, all non-structural items, finishes, partitions and services, it's about 400 kilograms. And we've been using, I know, talked lots about all the different things you can measure it against. We've generally been comparing to the Reba 2030 target, which I think is 500. So we still were well below that. And then actually on top of that, we have the values from the sequestered carbon in the timber as well, which would obviously reduce that further. I've added a note here about the light well. The light well is by far the worst part of the building in terms of carbon. It's piled concrete and it adds very little floor area. But actually, by adding the light well, it meant that the basement space, which would have otherwise been unused or used for storage and things like that, could actually be added as additional floor area that was lettable as office space. So I think the reason I mention it is because I think it's much better to have put the carbon or the worst use of carbon in a place where it actually makes a really big difference and means that there's parts of the existing building that can be used much better. And so, yes, that is the worst part, but actually it does make a really big difference. It made a big difference to the client, and it meant that there were parts of the building that could continue to be used as part of the new building in an efficient way. So in the end, overall, I hope you agree that we achieved what we sold the client, which was a really beautiful aspirational building that was also low carbon. The view on the left-hand side is from Pentonville Road, and the view on the right-hand side is from one of the roof terraces. This perforated aluminium cladding is around the CLT roof extension, and it has a very lovely view of St Pancras from the roof. And that's it from me. Thank you, Will.
No, that's brilliant. Thank you, Anna. I mean, it's another really good example, isn't it, of how reusing what we've already got doesn't have to mean, you know, there used to be preconceptions about that. Oh, it would have been nicer to just have a new building, but I mean, you wouldn't even know look at, if you walk down the road, if you walk down and look at York House, you wouldn't know that it was an existing building with a small extension on the front of it, I don't think.
No.
Quite a good transformation. Thank you for presenting on that. We've got 15 minutes or so for Q&A. Keep the questions coming in the chat, and I'll try my best to squeeze in as many as we can. I'm going to pose the first question to Rosie, because we've had a couple of questions around planting trees and on security in Rwanda, which I thought you might be able to answer for us. So firstly, how much tree planting was required to offset the construction of Rika? And I guess whilst answering that, you might give us your thoughts on how you would apply this to a different project. Say if you were trying to build something in a city, what would you do then in terms of, could you plant trees, or would you have to look at something else? And then the second question, which is very Rwanda specific, but I think we should ask it anyway, security when sourcing materials, and I don't know if that means in terms of sort of life safety security or supply chain reliability, but maybe you could talk a bit more about material sourcing for Rika as well.
Yeah, so obviously for Rika, we had the benefit of a huge site. It was a major project with major infrastructure, and so the tree replanting that is planned is around 40 hectares. That's just approximate. It's still a work in progress, but obviously, yes, significant area there that might not work on Pentonville Road, for example, where you're really just going to be confined to things like green roofs, and you might need to target a much lower embodied carbon in the first place. And in answer to your second question, Rwanda is very safe despite probably the history that it's associated with. So in terms of like personal security, going and sourcing materials, that wasn't an issue, but the supply chain security was. So for example, a lot of the timber that we have in Rwanda that's available at the market, that comes from DRC or other unknown sources where the forests are not necessarily managed sustainably. And so in order to not contribute towards deforestation, we had to make sure we knew exactly where our timber was from. But we also accidentally kind of confined ourselves to one supplier by using New Forest because they had a specific size of kiln, which was 4 meters. And so then when they actually couldn't meet the demand during construction and we had to look elsewhere, we were finding regionally some kilns were 3.5 meters. So we couldn't use those. And eventually we managed to source some of the remaining timber from Tanzania, but it was a struggle. And at one point, the contractor was saying, let's just use steel. You're wasting my time here. And so we had to fight pretty hard and do some of the kind of procurement hunting ourselves to make sure that we really ensured we could meet our project brief.
Yeah, it's interesting that the default of could we just go back to doing it as usual, please, was being asked throughout the process. We had there was a question in the chat for Lachlan and Ricky, which was sort of similar in a way. It's to do with what on the timber scheme adds complexity, adds differences. The question itself was on did going timber reflect floor to floor height and affect total building height, and how does that affect your facades? But I wonder if maybe Lachlan, you want to pick up on it. Is there anything else within the timber scheme that you designed that made things tricky compared to the business as usual of doing things in PT in Australia?
I mean, there's a whole presentation on this subject probably. I think the challenge, and just elaborating on Paul's question, I think he was talking about whether we had to go bigger floor to floor and whether that was changing the facade area, which we didn't really, because I don't think there was huge constraints. It's in a regional Victorian town, so they did have the envelope for their building, but they actually had quite generous floor to floor. But interestingly, what they did choose to do was we had primary beams with secondary beams and then the CLT slab spanning over the top to create this open space floor area. And they opted to drop down the primary beams and have them featuring down into the room space because it had to have a ceiling in it. And so that when you walk through the building, you actually got this sort of timber you knew you were in a timber building. And but I mean, we're having some of the same issues in embodied carbon and a space as well in Australia, is that we've got limited suppliers. When we're trying to put numbers down towards what's happening here, we're relying pretty heavily on the EPDs from one supplier because it's really the one company that's doing localized timber products. And for Ballarat Gov Hub, they actually ended up supplying the timber from Exlam Dolomites, which is an Italian company. So there's a transport study that we also did looking at what effect that actually had on the project. And the short answer is, if you can source locally, it would be a better outcome.
Well, thank you. And then I've got a similar question for Anna. I mean, I don't want to dwell too much on timber because we've got a whole timber conference coming next year for people who aren't aware of it. So watch this space. There's going to be plenty more around timber, but we are getting lots of questions on the topic. So Anna, on York House, could you maybe talk to us a bit about the use of timber in terms of fire, moisture ingress, insurance, things like that? What complexities did that bring for you during the design?
Yeah, we did have a bit of fun with that. Grenfell happened when we were kind of halfway through the tender, which obviously made everybody sort of panic a little bit about the fact that we were putting all of this timber everywhere, and we were higher than the height that everybody seemed to be starting to suggest was an issue. But generally, I actually don't think we had a massive issue with the insurers in terms of the fire engineering, but the client was nervous about it. But we generally were able to prove that it was something we had already looked at, it was something that the CLT supplier had looked at, and that we had all of the information to demonstrate that in the event of a fire, that shouldn't be an issue, that the charring of the CLT was sufficient and that it should remain in place, and the coating that had been applied to the CLT should be preventing the spread of flame sufficiently that it wasn't going to add to a fire situation. In terms of moisture, we had some issues during construction with trying to protect it whilst it was being built, to make sure that there weren't any issues with moisture. And I think some of the wall panels did at one stage get wet, and they had to put some heating inside that space really early on to dry that out again. But that was all again checked by the CLT supplier, that it wasn't we hadn't had any delamination or anything like that. It was just on the surface. But yeah, there were lots of conversations around when the waterproofing membrane was going to be applied to try and make sure that that space was protected from really early on. In the long term, I know there are sometimes issues where the water can, I think, get below a waterproofing membrane, and in the timber you don't necessarily notice it until it's far too late. We had talked to them about that kind of risk, but generally wasn't really considered to be a huge issue. I think, again, we discussed it with the CLT supplier, and it wasn't something they were particularly concerned about either. So yeah, and I don't think that was an issue with the insurers either. I suspect if you were doing this building now, you would have more issues in terms of, but not the moisture would probably be pretty similar. The fire, I think you would have much more issues with, but I think generally there would be other issues associated with the CLT at the moment. I mean, the cost of CLT at the moment is crazy, related to Brexit and COVID and everything else from the last year and a half. I don't know whether you would do it at this point in time, just because I think it would be so difficult. I think we would have been looking at a timber joisted solution or something similar if we were trying to put timber in now. But at the time, it was all discussed, but it wasn't a massive problem.
Yeah, that's interesting. And yeah, interesting comment there about whether it might have been a timber joist solution, which I think there's a whole other presentation we could have around when to use CLT versus when to use traditional joists. I think a lot of people jump on CLT and glulam as being the only way to do timber buildings, and potentially use a lot more timber than we maybe need to. So yeah, good point there. I want to ask you, and I'm going to ask this to Anna first, but it's kind of a question that's been aimed at everyone. all the projects? I'm going to pick on you, Anna, first, because there's a second parallel question that I'll also give to you. So we've had a really nice question here about how your projects address the circular economy and how you maybe thought about end of life, or did you think about end of life? Did it come up in your project? Did you get asked to think about how easy it would be to disassemble the whole building or the extension on the building, in Anna's case, I guess? And for context, the parallel question that was asked was to do with archive information on York House. So, how good was it? How helpful did you find this? And therefore, how critical do you think it is that your own information is passed on to as part of addressing your own end of life? So they kind of all go together, I think.
I could talk for weeks about archive information. Not in relation to this job, but it's something I've spent a lot of time looking through archive drawings for various buildings. But on this project, we didn't have any. We had to do it all from surveys and materials testing, and we did a lot of testing at the start. My opinion would be that it's incredibly important to produce a set of drawings that represent what was built, and that somebody somewhere puts them in a sensible place so that somebody in the future has got a chance of finding them. And in terms of keeping buildings and being able to reuse buildings, that has to be what happens. That has to be the most important thing, because how on earth can you, well, I mean, you can, but it's so much more efficient to be able to reuse a building and add to it and extend it if you know what was built and what the person who designed it was thinking, and how they were going about looking at that. So yeah, I think that's really important. I can't remember what the first part of your question was.
And the other piece is on, did you ever have conversations around disassembling your own? As part of it.
On this project, I don't know that we did particularly. I think it's something that for us as a company we have started to do much more, and with projects that we're doing now, it's definitely something that we are looking at and would be considering. I mean, I think with this project, it would be relatively easy to take it apart. It's how easily you could reuse the materials, and I think that that's probably a bigger industry-wide question about materials that you take out of a building and how you can reuse them and how you prove that those materials are suitable to be reused. It's something we've come up against in other places. You take a steel beam out, you know what grade it is, you know what size it is, but you can't put it back in. Seems kind of crazy, and I think with CLT you would probably have a similar situation. If you had the drawings, you'd know what size it was, you'd know what grade it was, and yet I'm fairly certain that you would have issues putting it back in. And I think that that's a probably wider industry question about regulation of those types of things and what you would need to do to prove that.
Yeah, I agree. Thanks. I'd love to ask the same question to the others, but we're now at 12:15, so I'm going to have to move on, which means, we're going to have to, everybody's going to have to go away and do their own imagining as to what happens when Rwanda stops farming animals and you have to repurpose Rika as something else. Thank you for your time, all of you. I think 3 really interesting projects, lots of parallels, actually, despite the fact that they're all so different as projects, lots of parallel thought process that you all had to go through, and thank you for sharing that with the attendees today. I guess I'm going to put my screen back up for 5 more minutes. Been asked to sort of give some closing remarks. Thinking through all of the content that we just heard over the last 3 hours, these are the sorts of things that jumped out at me as having come up again and again and again, which is interesting. I mean, we've talked a lot about 50% reductions by 2030, and it's come up in multiple presentations. And about the need to think holistically beyond just structures in order to achieve that. That's not just within our own part of the project, but how do you help other disciplines get their emissions down too? I don't want to lose track of Caroline's presentation on resilience and risk. I think it's incredibly important that we don't just try and design in a way that minimizes global warming, but we also design in a way that anticipates the unknown of what's going to happen when we end up with 3 degrees global warming anyway, but doing that in a way that gets the balance right I think is really, really hard, but really important, and kind of fits under holistic thinking again, I guess. I think the case studies at the end really do exemplify that, you know, whilst this is a global problem and there are different solutions in different places, if we keep sharing globally, we're only going to be able to solve things quicker. And we saw how much overlap there was between those 3 projects, and I'm pretty sure you could pick another 3 again from another 3 different countries, and again we'd just get more and more overlap. For those of you who are members of the institution, don't forget we are a global institution. We do have members all over the world. So if you are interested in getting in touch to ask, well, what can I do in my own country? Or I have done this, how do I share it? Just feel free to email me, and we'll try and work out what best to do with that question or that information. Final reminder for day 2, as if I haven't mentioned it enough times already. Next week, it will be a few hours later than this one was, to allow the Americans to join us. If you are dialing in from Australia at the moment, I have no idea what time you'd have to get up to listen to this. So apologies, we'll just assume you won't make it. We will, of course, record all of day 2, the same as we've recorded all of day 1. So you'll be able to watch the content back afterwards. But if you can join us in person, please do. We've got excellent presentations on 3 different materials coming from real experts who understand those subjects. And we'll be able to give you a sort of unbiased, impartial view on how to treat these materials when it comes to carbon emissions. We're going to go into carbon on site and carbon in bridges. I noticed there was a question that we didn't get onto about infrastructure and heavy structures. And so when Cameron talks about bridges, we're probably going to talk a lot about life extension as much as design of new builds. So that should be really good. And then we'll finish day 2 focusing on circular economy, design for disassembly, material databases, all of that kind of stuff. Anna, you should get your clients to listen into that bit maybe, so we can get all of your archive records kept on file for the future. And then we're going to be finishing off with a quick session on the sort of a glimpse into maybe what we're all going to be doing for a living in 10 or 15 years down the line and how we think that might change. I've also been asked to plug the iStruct's SME Business Practice Conference, which is happening the week after that. So if you are joining us and you work as a sole practitioner, you work in a small practice, maybe there's only 10 of you in the firm, this is a really good conference to come along to. It's not just a sustainability conference, but there will be a sustainability part to it. And we've got some good speakers feeding back work that they've done within their firms around carbon and around the way they approach design. Lots to be learned there. And there's a discount code on there. If you quote CEC at checkout, then you get 20% off, which who doesn't like a good discount code? That's it. Thank you again to all of our wonderful speakers for turning up and presenting today, and for giving up your time to prepare and present on some amazing projects. And of course, do go onto the website if you haven't been already. All of the sorts of things we talked about today are available to download, and we will put up links to the videos of the recordings on the website when it's complete. Except for that, enjoy the rest of your day, enjoy your lunch or your breakfast or your dinner, depending on where you are. We'll just go to bed, and hope to speak to you soon.